Hello students, welcome to video lesson 11.1. In this video we're going to talk about something new. We're starting chapter 11, which is all about what we call rational expressions. Okay, these rational expressions are built upon polynomials, which we've been talking about since chapter 7, 8 and 9 particularly. So a rational expression is defined here as basically a fraction where both the numerator and denominator are polynomials. Okay, now we allow polynomials to have a very broad definition in this case, but that is our definition for rational expressions. Okay, a fraction where both the numerator and denominator are polynomials. So I've listed some examples here for you. Here's one, 3x plus 4 over x minus 2, where both of those are linear expressions. 4 over x squared plus x minus 2. Here we have just a number, but remember I said we're giving polynomials a very broad definition. So a number can be a polynomial. It's just a monomial of one term with a degree of 0. Okay, so 4 is considered a polynomial, and then the bottom obviously is a quadratic equation like we're sort of used to seeing. And then here we have two monomials that actually have two different variables in them, and that's okay as well. So there we have 5x to the 8th y to the 5th over 2x squared y to the 3rd. So all three of these are examples of rational expressions, and what we're going to be asked to do today is to simplify these rational expressions. Okay, so essentially we're taking simplifying fractions up a step. Okay, so we're going to have to recognize factors in our numerator and denominator. Okay, and by factors we mean things that are multiplied to make whatever we see there. Okay, so we're going to do a lot of factoring. We're also going to be recognizing sort of common pieces in the top and the bottom, the numerator and denominator, and we're going to cancel those out, and what's left is going to be the simplified form of that rational expression. Okay, so for example, we're going to start with this example. Okay, and when we simplify a rational expression, step number one is always to factor everything. Okay, factor everything. So that means the top and the bottom, as much factoring as we can possibly do, separating these polynomials out into separate pieces that are multiplied together to make the polynomial we have. Okay, so here in the numerator of this expression, 3x plus 9, the first thing that I always want you to look for when we're factoring, of course, is a greatest common factor, right? Something that we can factor out, like undistribute from the terms. In this particular case, we can factor out a 3, right? 3x plus 9, we can factor a 3 out of both of those. And if I divide away a 3 from the first term, I'm just left with x. And if I divide away a 3 from the second term, I'm left with plus 3. So my numerator becomes that, and that is as much factoring as I can possibly do for the numerator. And now I'm going to do exactly the same thing for the denominator, except I'm going to try to make my fraction bar a little bit straighter than that. Okay, so now the denominator is a quadratic trinomial, and we've been factoring these in the past two chapters. In this one particular, there's no number in front of x squared, so we're just doing our multiply to 6 and add up to 5 sort of factoring, right? I need to find two numbers that multiply to make 6, add up to make 5. Now, if you're still having trouble with this particular skill, I will tell you that in these rational expressions, if you can factor, like we've already factored the numerator here, we already have a piece of x plus 3. Because I'm hoping to be able to cancel things out that are 100% exactly the same, I'm thinking that probably one of my two factors on the bottom is also going to be x plus 3. At least that's what I'm hoping. So let's think of two numbers that multiply to make 6 and add up to make 5. Multiply to 6, add up to 5 would be 2 times 3, right? Or 2 plus 3. So my two factors on the bottom become this, x plus 2 times x plus 3, okay? So there I have factored everything. Step number 2 is cancel the same stuff. I will say the same factors, and I'll get into why I'm saying same factors in just a second. So in this particular case, the only thing that's the same here is this parentheses x plus 3 with this parentheses x plus 3. So I'm going to cancel those. Right, so the x plus 3s are gone. And then what's left is my simplified version of this rational expression. So it becomes 3 over x plus 2, okay? 3 over x plus 2. Now, it's really, really important that when we are canceling things, we are only allowed to cancel things that are being multiplied to something else, okay? We are never allowed to cancel anything that's being added or subtracted to anything else. So, for example, in this case, there's a 9 right here and there's a 6 right here, right? Well, the 9 and the 6 could cancel out, right? If I had a fraction that said 9 over 6, I could cancel the 9 and the 6. I could divide both of them by 3, right? So I could reduce the 9 and the 6 down to 3 over 2. I am absolutely not allowed to do that in a rational expression, okay? I cannot do that. I also cannot take this x right here and this x right here and just cancel them out and pretend they don't exist, okay? Because these terms and these pieces are being added to something else. I have to factor first before I can cancel, so that when I have a factored form of the numerator and denominator, all the pieces are then multiplied together. That's sort of our definition of factors, right? Things that are multiplied together. So make sure that you don't cancel things too early just because you see the same thing on the top and bottom, okay? Unless it is multiplied to something else, you cannot cancel the same thing on the top and bottom if they are connected with addition signs, okay? And I will reiterate that as many times as I possibly can throughout this chapter, all right? So that is the first example where we have a quadratic that we need to factor into our sets of parentheses. We have a linear expression that we can factor out a common number. And again, we arrive here at an answer. Whoops, that's supposed to be a square. Undo box. Right, there you go. So that expression is the simplified form of this one, 3 over x plus 2, all right? So if I look then at this example, this one is slightly different, right? Because this does not have any plus or minus signs. It's just a whole bunch of stuff all being multiplied together. So if I think about what the numerator is, right, it says 8, whoops, gotta go back to my pen. It says 8 times, and then x to the third is really x times x times x, right? And then it's y to the 7th, so it's y times y times y times y times y times y times y. That's what the numerator says. 8 times x 3 times y 7 times, right? And then the denominator has a 14 times x 5 times and times y twice. So these are all factors, right? They're all being multiplied together, all being multiplied to everything else. So we can go ahead and just cancel things out. We actually did problems like this previously in chapter 7 when we were talking about exponents. Okay, and we talked about how we can subtract the exponents on our variables, right? And we can simplify our numbers just like a fraction. So if I go ahead and do that in this case, the 8 and the 14 are both able to be divided by 2. So the 8 can become a 4 and the 14 can become a 7, right? So it's 4 and it's 7. I got that. And then I have x to the third on the top and I have x to the 5th on the bottom. So 3x's on the top, 5x's on the bottom. The 3 on the top can all cancel out with 3 of the ones on the bottom. 1, 2, 3. And I'm left with 2x's still on the bottom. So I end up with still an x squared in the denominator. And then y to the 7th over y squared, 2 of the y's from the numerator can cancel with the 2 from the denominator. 7 minus 2 leaves me with y to the 5th on the top. Okay, so this is my simplified form. And this one came simply from recognizing all the pieces that I already had multiplied together, canceling out just like we did back in chapter 7 with our exponents, okay? So when there's no plus or minus signs, just assume everything is multiplied and you can cancel whatever it is that you want or subtract your exponents on your variables, okay? Now, the last example I'm going to show you actually needs one extra piece of information for us, okay? And that piece of information involves flipping two numbers or two terms around a subtraction sign. Now, in general, hopefully we remember that when we add things together, it doesn't matter what order we add them in, right? If I do 4 plus 5, that's exactly the same as 5 plus 4, right? I can flip things around an addition sign and it doesn't change anything. So always keep that in mind, right? If I have one term, like on the top it says x plus 5, and on the bottom it says 5 plus x, well, those can just be canceled out, right? Because they're really the same thing. X plus 5, 5 plus x are the same thing. That is not true for subtraction, right? So when I have subtraction, if I have, let's say, well, I'll do numbers first. If I have 7 minus 3, that is not the same as 3 minus 7, right? 7 minus 3 and 3 minus 7 are not the same answer. One is positive, one is negative. So what I can actually do is I can flip things around a subtraction sign if I put a negative sign in front of the whole subtraction problem. Okay, so here's what I mean. If I do this, if I have 7 minus 3, that's the same as negative, and then in parentheses, 3 minus 7. Okay, so I flip the 3 and the 7 around that subtraction sign, but I have to put this negative sign in front of the whole subtraction problem, okay? So that example in algebra is, here. I have x minus 5, and I can flip those around to 5 minus x. Instead of x minus 5, it's 5 minus x, if I put a subtraction sign in front of that set of parentheses, okay? Now, it's sometimes necessary to do that so that we can cancel common terms or common factors in a rational expression, right? So for example, here's an example that I can simplify. I have 14 minus 7x and 5x minus 10. Remember that step number 1 is to factor everything I possibly can, right? Now, both of these, neither of these are quadratics. They're both just linear expressions that have a common factor that I can factor out or undistribute. So 7 can be factored out of this top expression, right? The numerator can both be divided by 7. 14 divided by 7 is 2, and 7 divided by 7 is 1, which just leaves me with an x. Okay, so the numerator becomes 7 times 2 minus x, right? And then the denominator here, 5x minus 10, they can both be divided by 5. 5 is a common factor for 5x and 10. So I can divide both by 5, and I'm left with x, and then 10 divided by 5 is 2, okay? So now notice that I have these parentheses on the top and bottom of the fraction, and they look very close to being the same thing, except one is 2 minus x, and the other is x minus 2, right? See how those things have been flipped around? But remember, I can actually do the flipping myself if I add a negative sign to something, okay? So what I can do is I can take the numerator, and I can, instead of it being 7, I can make it negative 7. I put that negative sign in the front. That allows me to take the two pieces of the parentheses and flip them around the subtraction sign. So now it says x minus 2. Why is that helpful? Well, it's helpful because now I have a set of parentheses in the numerator and denominator that are the same, right? That I can cancel. So I cancel out x minus 2 with x minus 2, and I am left with simply negative 7 over 5. So this whole expression here is really equal to negative 7 over 5. Okay, negative 7 over 5 is the simplified version of this rational expression, okay? Now, this is all I'm asking you to do in your practice problems, okay? Your practice problems may talk about something called excluded values. We are not going to do anything in this section with excluded values, okay? We're not going to worry about that. So you can forget those directions. You're simply going to have to simplify the rational expressions by factoring everything out as much as you can and canceling whatever's the same on the top and bottom, okay? If you need to flip things around a subtraction sign to make them the same, put a negative sign in front of one of those sets of parentheses, okay? If you have any other questions about anything, do please reach out to me. Let me know. I'd be happy to help. Otherwise, that's all I have for you, and we'll talk to you soon.